I'm going to use this Fritzing diagram to illustrate the connections that we're making on the components for the Lancer Pursuit craft. There are two major components that are breakout boards. Those are the things that are blue. The breakout board on the left is a 12-channel LED controller, which allows me to plug up to 12 LEDs and control the brightness using one communication channel. On the right, the smaller board is an Adafruit Trinket 3 volt. This is a microcontroller board that can program via USB port, and then I'll use it to read the state of the button and send signals over to the LED controller to change the brightness or can change which LEDs light up. Now, you may notice that this is a different programmable controller than the one I used earlier. In the earlier videos, I showed that I was going to install an Adafruit Feather 328P, which is a larger device with a power regulator. But it turns out that I don't actually need a power regulator for the entire thing since I have that in the base. So I went ahead and swapped it out for a smaller controller, which makes it easier to fit everything inside. Now, the two green boards aren't actually boards that appear inside of the Lancer Pursuit craft, but they are going to represent the components that we install. Namely, there's going to be a what's called the JST connector. That's going to be our power pigtail. And then there's going to be the tactile push switch button that we're going to use to help us switch the turret arc indicator. The first thing we're going to do is rotate the PWM controller. And the reason why is because most of these connections that have rotated to the inside are going to end up close to the trinket. What I'm going to connect first is the power pigtail. I'll connect the ground port on the power pigtail. That's going to be the black wire to the ground on the PWM controller. The next thing I'll connect is the V+ pin. V+ typically stands for, well, obviously positive voltage, but the important part here is that this is where we supply power into the LED controller itself. It can be a varying voltage range. For example, over here, the Trinket only sends out 3-volt signals, but the power supply itself can be a lot higher. For example, it could be a 5-volt signal or a 5-volt supply like we're receiving from the power controller inside of the base. Once I've tested my wiring by plugging in the power supply into the LED controller and seeing that I get a status light on the LED controller, I'm going to continue to wire up power into the Trinket. Now you'll notice on the other side of the PWM controller, there are 5 other ports. The idea is that these controllers are meant to be daisy-chained to each other, so you could control 24, 36, or even higher numbers of LEDs. What I'm going to do is use the voltage output from this side and then connect it over to the battery input on the controller. The Trinket accepts a 5-volt connection or a 5-volt supply because basically that's the type of supply that's received through USB. So this is perfect for us. The next thing I'm going to do is connect the ground over to the ground pin. And then once I've connected both the battery and the ground pin, the Trinket should receive power. And I can test it once again by plugging in the whole thing and seeing that I get both the status light on the LED controller as well as on board the Adafruit Trinket. The next thing I'll wire up is the tactile push button switch that I'm going to use for the turret arc indicator. What I'll do is I'll connect the wire from port 3 into the switch and then from the switch to port 4. The idea is that when the switch has been pushed down, when the button has been pushed down, current is going to be able to flow through the switch from port 3 into port 4, and then I'll be able to read the state. And if the button is pushed down, I can trigger some type of turret arc change. Now, when I wire up these switches, I do want to make sure that I use a little bit of heat shrink tubing to make sure that the long extended legs are not actually going to touch anything else and conduct or ground out. This is a single pole dual throw switch, which means that if I push the button, it actually bridges 2 separate sets of connections. That's the second throw, which are the other legs. What I'm going to do over there is I'm going to just clip those legs off to make sure that they don't interfere with anything else if they happen to touch things like, for example, exposed copper pads on any of the other controllers. The final 3 connections that I'll make are the logical connections from the Trinket 3-volt controller to the PWM LED controller. The first thing that I'll connect is 3-volt to VCC, and I'll make that an orange wire. And then the pin number 2 from the Trinket over to CI, which stands for clock in, make that a yellow wire. And then from 0 over to DI, which stands for data in, and I'll make that a green wire. The CI and DI pins are what are called clock in and data in pins, and they're part of what's called a serial programmable interface. It's basically a way for the 2 boards to talk to each other. In this case, what's going to happen is that bits will be pulsed across the DI pin, the data in pin, and then a clock signal will be pulsed across the CI pin to tell the board when to receive individual bits. The other connection, VCC, controls what's called the logic level. Because the Trinket is operating at 3 volts, the LED controller needs to know exactly what voltage those CI and DI pins are going to be sending. Therefore, we tie the 3-volt pin from the Trinket 3 volt to the VCC, and that provides what's called a reference voltage. Once this whole thing is wired up, the next step will be to program the Trinket with some instructions on controlling the LED controller, and then testing to see whether or not I can get the LED controller to light up some LEDs. Thanks for watching.